ancient Greece, slavery was a practice for manual jobs and household service. Ancient Greeks complained and swore that work was a curse and nothing more. Escaping work, esteeming leisure, were deemed to be a free man's pleasure. Today's humans are still the same as today's slaves. Have robots for a name. Manual jobs, household service are still an aim, but today's humans have more to claim. My name is Sahar, and in Brno, tonight I am to participate in the European Science Slam. The research I'll present was done at EPFL. It's in robotics. By now, anyone can tell. As for the subject, you still have to wait. And in the meantime, any presentation must have a date. So, what do we want from robots these days, apart from seeing them in movies and plays? We want a worker and a space explorer. We want a friend, and sometimes a girlfriend. We want a surgeon, and for the elderly, a companion. But to work with robots hand in hand, these robots definitely need a hand. Now we reached my research core, which in conferences might be a bore. But bear with me for a few minutes more. Tonight, I promise, we won't hear a snore. My research is on robots' hands. This subject is in very high demand. I teach robots to use this tool they learn to grasp. Isn't that cool? The key to this grasping methodology is for robots to learn humans' strategy. So that's the goal of my research subject: help robots imitate humans in grasping objects. But that's very challenging, one might say, because robots' hands are structured in a different way. So how can we teach them what our hands know when their fingers differently grow? How can we close the structure gap so our hands and theirs together clap? The trick is to model humans' grasp and use some math to describe a clasp. Math is the way, there's no doubt, to transfer man's knowledge to a robotic crowd. So we used a sensorized glove for people to wear and the task of tracking their fingers to bear. So the glove can track the hand's motion. But what about the hand's emotion? How can we distinguish a gentle touch when holding an egg from a very firm grip when hammering a peg? So we covered the glove with tactile sensors so we can measure forces and tensors. The end device was bulky to wear, but it wasn't heavy, I swear. With this step, human grasp modeling became possible. Motion, forces, and torques were tangible. All of these variables were put into an equation to describe human object manipulation. The formulation was for any hand structure accessible, rendering grasping for robotic hands possible. This is a demo of the final methodology, starting with a three-fingered grasp strategy. This robot is five-fingered, but still very angered. But if you put any wine glass in its hand, even if it's empty, you can make him again cheerful, or at least less grumpy. To capture a human's grasp, there are several ways. Till now, we focused on the sensorized glove displays. But we all know that in order for the fingers to move, first the muscles need to approve. Each grasp order is encrypted in the muscles' activities. To decrypt these orders, we studied the muscles' modalities. This is feasible through EMG, or electromyography, measuring the muscle electrical activity.
So we're using EMG signals from the forearm in order to be able to control a robotic hand. And first, so we need to study the reaching and motion, reaching and grasping motion. So we need to be able to classify the different grasp from the EMG signals as early as possible. So Jason here, he has all these electrodes that are measuring the EMG signals, and then he will performing a grasping motion, and then we will see how the hand will do the same gesture as he's doing.
To apply this EMG control-based controller to an assistive robotic device or a neuroprotective device.
Working with robots is not as smooth as it might here shows. Dealing with hardware is full of flaws. Sometimes they just go crazy on you. So always make sure to keep the red button near you. This button ensures your safety by shutting the robot down. So in the next video, watch the hand closely and how it let us down.
Okay, so what's the ultimate aim of this research?
So I think that the main application of that one, of that project that we're working on, is somehow apply the controller that it's based on EMG signals to an assistive robotic device or a neuroprotective device. So this is like the ultimate goal of all the project that we're working on.
And how... Should we repeat that?
Ladies and gentlemen, I hope this gives you a real good sense of my research on robots and their awkward hands. But the question is, how robots and humans will together evolve? Will they outsmart us and our problems solve? Or will we evolve to become their slaves? Will they bring humanity back to the caves? Or will they become the other self, perhaps a more efficient version of ourselves? This research definitely challenges humanity and forces us to reflect on our identity. Thank you.